All right, welcome back, everybody. Glad you are here today. We are going to be talking today about how we rationalize denominators. Um, Basically, what we mean when we say rationalize denominators. So, what we're saying is that we cannot, in math, this is something that's went on for a long time, have a square root in the bottom of our denominator. Now, looking at this, the way you actually deal with this, so there's a couple different ways, but the primary way you are going to deal with it is you are going to multiply the top and the bottom of your fraction by whichever square root is in the bottom that we are trying to eliminate. So in this case, it would be the square root of 2 and the square root of 2. Now, when we come over here and we do this, just like with multiplying fractions, the way you multiply fractions is you multiply across. So if I have 1 times the square root of 2, this of course will just stay as the square root of 2. Now on the bottom of this, the square root of 2 times the square root of 2, that's going to give us the square root of 4. Now if you notice, our square root did not disappear, but here's kind of our secret. When I take the square root of 2, well, hold on, wait a second. If you look at this, isn't the square root of 4 just equal to 2? So maybe the square root actually did go away when we did that, right? That's the trick to make this eliminate. Now, I want to try to shortcut that a little bit. And I want you to notice something. Whenever you multiply the square root of a number by the square root of that exact same number, so in this case we had 2 and 2, whenever you are doing that, what you in fact know and can make sense of is that essentially the two square roots cancel each other out, and you're just left with whatever was inside the square root, which is why 2 ends up in the bottom of our fraction. So we're going to try to make sense of that as we do a few more problems. So here's another problem. Now, we don't care at all if there's a square root in the top. It's only those square roots in the bottom that are of concern to us. So to get rid of the square root in the bottom, we are going to multiply by the square root of 3 over the square root of 3. Now, when we do that, up top, the square root of 2 times the square root of 3, this is going to give us the square root of 6. Now, in the bottom, when I take the square root of 3 times the square root of 3, since these are the same thing, the square roots essentially cancel off, and we are just left with 3. So we are just going to have a 3 on the bottom, which makes this our final answer because the square root of 6 doesn't get any simpler. Let's look at another one. So here's another one, number 5. Now, number 5, there's a really easy trick we can take advantage of here, but we're going to pretend we don't see that trick, and then we'll come back. If you want to get rid of the square root of 25 in the bottom, you're going to multiply both sides by the square root of 25 and the square root of 25. Now, when you do that, you're going to end up with 4 square roots of 25 over, now again, these are the same square roots, and we're multiplying them, so they're going to give us whatever number is inside the square root. Now, we do have some more work to do here, right? No radical problem is ever simplified if we don't simplify the radical. So the square root of 25, hopefully at this point we've gotten to the point where we know that is just 5, and 4 times 5 is 20 over 25. Now, 20 over 25, that's a fraction. And we always reduce fractions. So if we reduce this, 5 goes into 20 4 times. 5 goes into 25 5 times. So we can make this into 4 over 5, which is the absolute best answer we can get. Now, let me shortcut that big time for you. If you come back to the original, right? This is the process, right? That's the process we're going to follow on 99% of problems. But there's always those special situations that you should look out for. And here is one of them. If we know the square root of the number, right away, if you realize that the square root of 25 is just 5, then you can replace the square root of 25 with a 5, and you're done. There is no more square root in the bottom. And if you notice, between the two of these things, our final answer is exactly the same, only taking that shortcut allowed us to do way less work. So we'll try to keep an eye open for that in the future. Here's another problem. So coming over here, we have 1 divided by the square root of 8. So what we're going to do is we're going to multiply by the square root of 8 over the square root of 8. Now, 1 times the square root of 8 is just going to be the square root of 8 up top. On the bottom, I know that the square root of 8 times the square root of 8 gives me just 8. Now, we do have some more work to do on this problem. We still need to come up here and simplify the radical. So hopefully at this point we've gotten really proficient at this, and you look at 8 and say, I could break that down into 4 and 2, and 4 would be 2 and 2, and you can maybe even skip the prime factorization tree. So we're going to pull a 2 out, and we will end up with 2 square roots of 2 up top with an 8 on the bottom. Now there's one last piece of simplifying we can do here. Since 2 and 8 are both outside numbers, you can reduce them just like a fraction. So 2 goes into 2 one time, 2 goes into 8 4 times. So our best answer here would be 1 square root of 2 over 4, which would be our final answer. Now remember, if the 1 is there, that's like a take it or leave it piece. It doesn't need to be in our answer, but it certainly can be. Let's look at another one here. So when we see this now, hopefully what we start to realize and recognize is that, well actually, hold on. You've not seen a big square root yet. All of these other ones have been little square roots. Now there's a fact that's known in math that whenever you see one of these big square roots, you can actually just break it into 2 smaller square roots, just like we did. A big square root is just a small square root on top and a small square root on the bottom. Now, let's pay some attention here for a second. Remember we were looking for those shortcuts. Look at this, 144. That is a number we absolutely should know the square root of. The square root of 144 is just 12. So instead of writing this, let's just write what it's equal to, which in this case is 12. Now, we do have the square root of x squared up top. So let's go back in time here. If I have the square root of x squared, that's just xx. So if I have xx, I take those 2 x's, I pull 1 to the outside. These 2 go away. There's nothing left. The square root's gone. So we're just left with an x, which is our final answer. There's nothing we can do more. We can't reduce the fraction. You also don't have any square roots left, and there's definitely not a square root in the bottom. That's the goal. Get rid of square roots in the bottom. Notice how no square root in the bottom, 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 and no square root in the bottom. Okay, that's the goal, ladies and gentlemen. Let's look at the next page here. Oh my gosh. The next page is absolutely 100% review. You know how to do this. I'm not going to do it. I'm going to save it for you. You know how to do this. I'm not going to do it. I'm going to save it for you. You know how to multiply these. I'm not going to do it. I'm saving it for you. You know how to subtract. I'm not doing it. I'm saving it for you. Number 19, let's be real. That one is tough, though, so I'm going to help you out on this one. So 6 times 6. This is our double distribution. 6 times 6 gives us 36. Then we go ahead and we multiply the next one. 6 times negative square root of 3. If you want to put a 1 in front to help you out, you're certainly welcome to do that. 6 times negative 1 is going to give us a minus 6, and the square root of 3 is going to get tacked on there. Now, as we continue our double distribution, we're going to have the square root of 3 times 6, or 1 square root of 3 times 6. 1 times 6 is going to give us a positive 6. Square roots of 3. And then as I make my last multiplication, 1 square root of 3 times the square root of 3. Hopefully you see it. That's just going to be 1 square root of 9. Now, as we go through, we got some simplification to do here. Notice we do have like radicals, so we can combine these. If I have negative 6 square roots of 3 plus 6 square roots of 3, they actually cancel each other out. Bye-bye, they're gone. We're going to have 36 right here, plus 1 square root of 9. Now, square root of 9 is a special number. It's a perfect square. You can take the square root of it really easy. The square root of 9 is 3. 1 times 3 is 3. So this whole thing just becomes 3. So I have 36 plus 3, which of course gives us 39. Look at that big old ugly problem simplified down to be a really nice, compact answer. Your work today, ladies and gentlemen, is to finish the rest of this worksheet. I've already done 1, 2, 3, 4, 5, 6 problems, which means of the 20, you have 14 remaining, and I think you're going to be able to tackle those. Pretty straightforward. If you're struggling with how to to rationalize the denominator, which is our new topic, make sure you are reaching out and asking. Thanks, guys. Have a great day.